So I'm going to talk about how to change a graph or shift it, and start off with an example with a parabola, or just basic equation, which is just start off like this equation right here for this graph is y equals x squared, and in order to change it we have an equation which is y equals a times x minus h squared plus k, and each of a, h, and k have a different meaning where they can change the graph in different ways. So to start out, we have the k value here, which is for shifting up and down, which means if you had basic equation, which is this, you had like y equals x squared plus 1. This means that every point will be moved up 1. So if it was to be a little sketch, it'd be like this. This is the origin, and then you have it up 1 because of that vertical shift. Now if you were to use or change the h value changes things from left to right. And so that means if you change this equation to something like y equals x minus 1 squared, this means that the graph, every point is moving over 1 to the right, because you take the opposite of what is inside the parentheses. So this means that you move this over to the right one. So it'd be like that, because it's moved over to the positive 1 instead of negative 1. You take the opposite, so it's moved to the right one. Now if you were to change the a value, this means that you're either vertically stretching or compressing it, meaning that it might look thinner, but it's not. It just appears that way. Or it might look like wider, but it's still just the same points, just multiplied by any number. So it could be like y equals 2x squared. This makes this graph look skinnier, but it's not. It's just multiplying this point by 2, this point by 2, making the values greater, but not making it actually skinnier. It might look skinnier, but it will stay the same. So it might be like this, where it might look skinnier, but it's really not. Or say if it was not 2 and it was a decimal, like if it was 0.5 or half, it would make the graph look wider. Without really making it wider, it just appears that way because you're condensing the value of each point. And now if you were to have an equation that has all 3 of these into it, it would have this basic equation, and then you just add in k, h, and a. So to use the same things I had before, we have y equals 2x minus 1 squared plus 1. And so an easy way to find your vertex, say how this one's at 0, 0, the origin, an easy way to find the vertex is to take the h and k values of 1 and negative 1, which will give you your vertex, your starting point, to help it make it easier to find where to start your graph. So remember that if it's in the parentheses, you take the opposite. So if it's negative 1, it becomes positive 1. So your vertex would be like 1 and 1, because this is also for the y value of the vertex. So if you were to graph that point, it would be right there. And then you should know that for points of a parabola, it goes like 1, 1. So that means you multiply it by 2 for the first point, so it just once again be skinnier. So roughly it would probably look more like this, a little skinnier in the base. And that's also, so it's multiplied. So you can check by looking over your equation. So you have positive 1, meaning it's shifted up 1, up 1. It's moved to the right 1 because of the fact that it's in parentheses, you take the opposite. So it's up 1, it's the right one. That's your origin, or your vertex, I mean. And then you know that you're multiplying by 2 or 0.5 or any number, but in this case it's 2. and that it makes the graph look skinnier, even though it's really not skinnier. And if you were to use a different type of graph, it's the same thing. Like if you had an equation for a different graph, like y equals ax minus h cubed plus k. It's essentially the same thing with each a, h, and k, these parameters, the same thing. Just the graph looks different. Where like with cube, the graph looks more like this. Just that each value just changes it, where it can be moved over one, up, down one, and stretched or compressed by a. And one more thing before we end the video is to make sure that you check for the sign of a, because this can really depend if it's open upwards or downwards. So in this case it's positive, but if it was negative, that means it faced down. So with this equation, the point would still be here for your vertex, but it would just be the same thing, just flipped, facing downwards.